Direction angles. If u is a unit vector such that theta is the angle measured counterclockwise from the positive x-axis to u, so this here, then the terminal point of u lies on the unit circle. So this is this. If I have this connected here at the origin and this has a length of 1 and I can spin this all the way around, what I'm going to create is a unit circle. It has a radius of 1. And these points here, these terminal points, x, y, are going to be on that unit circle. So this should look kind of familiar to you. We have this angle theta, we have this radius, we have our unit circle, we have this point on the circle. And we know that when we have a unit circle, the x component is cosine of theta, and the y is sine of theta. And you have the following. So u, its components are x and y. Therefore, its components are cosine theta and sine theta. And we said that the I represents the horizontal component and the J represents the vertical component. So we're caring about these here. This and this. Now this angle theta is referred to as the direction angle of the vector. And once again, they're reminding you here that the magnitude of the vector is 1. Its length is 1. We have a point. The point is broken up, or this vector broken up into its horizontal component, which is x equal cosine of theta, and its vertical component, which is y equals sine of theta. So suppose that u is a unit vector with a direction angle theta. If vector v is ai plus bj, is any vector that makes an angle theta with the positive x-axis, then it has the same direction as u, and you can write the following. Now, we've actually already stated all of these items. That's what we were showing here. Now, we have to determine the direction of, remember, we care about magnitude, we care about direction. We've already shown magnitude. Now we care about the direction. And it turns out that in this case, our direction, remember from earlier, we thought about the slope. Here, let me write it out here. We thought of it as delta y over delta x. Okay, well, we know that we're able to find that our y's are a result of sine theta, and our x's are a result of cosine theta. Therefore, tangent theta is going to be what determines our slope. Now, this is far more important than you realize at this point. In calculus, we're going to talk about the slope. God, like the whole first semester, it's so important to calculus. So this statement that we're making here is going to be something that will carry on through the first semester of calculus. And it's kind of cool that if you think about, I guess this picture here, finding the slope of this is as easy as taking this delta y and dividing it by this delta x. Well, this distance here is sine theta. This distance here is cosine theta. So the tangent of the theta is actually giving us the slope or the direction of the vector. Pretty amazing stuff how this all connects. All right.